Hello, welcome to module 15. So in this module 15, we're gonna talk about the next phase in the software testing, which is integration testing, okay? This goes along with the code review and also continuous integration and continuous delivery. So today we're gonna talk about the purpose of integration tests, why we need to do it, why is it useful? And we're going to discuss the strategies that we do for this kind of integration tests. And we discuss some of the challenges and the approach to test these kind of component-based systems. Okay. All right. So let's get started with the test size. According to Google, we can differentiate the tests based on their sizes. So the smallest version of the test is called the small test size, and it involves only one machine. So all the tests will be run on one single machine, and you're gonna test one single process of the software. So usually this is a unit test, but you can also have some kind of integration test if you have many modules or many processes that are in the same machine for the integration test as well. And then we move to the medium size test where you check for multiple instances or multiple processes of the software. Okay, this can still be some unit tests and it can be some of the integration tests. But after that, when the tests get larger, you go over multiple machines and you can have many processes involved and you get the full scale of the system. This will be mostly the system test where everything is integrated and you include all the other API calls, external features, external APIs, so on and so on. Okay. So today we're going to discuss mostly on this scale of the test size. So from this V model, we are now moving up from the unit test into the level of subsystem test. And the subsystem test is when you kind of integrate the module that you have in the software system together. We try to make sure that the subsystem or the design specs that we have, APIs between the module, how they pass around the value are correct. And what is integration testing when we compared it to the unit test that we have learned before and the system test that we're going to learn the next? So let's see at the unit test level first. Unit test, we test based on the specification of the module interface. Okay, so we try to see the method header, method signature. We try to see what are the parameters, what is the return type, and what is the return value. Okay, so that's based on the interface of the module that you are testing. And the structure that we see are the coding details. So the actual code, even we're gonna abstract it to a graph or we're gonna focus on the logic, but we are mostly based on the code or the implementation. We might see or might not see it depending on whether you're gonna do black box testing or you're gonna do white box testing. The scaffolding that we need, scaffolding means some kind of support, okay? And usually it becomes a mock module. We're going to discuss about the mock module soon. In unit test, it's a very specific to one specific unit or one specific method. So usually you do not require much of the scaffolding, but you might need some of them to get the task working. Like you might need to mock the database connection so that the method can perform the task, or you might need to mock some external API calls. And for unit tests, we mostly looking for faults in the module itself. So you only look at this self-contained module and you want to find faults inside those modules. Next, let's move to the integration test. So for the integration test, we use the specification of the interface or the breakdown between the module. So instead of just looking in one particular module, we are now more interested in how they are interacting with the other module. You can think about it as having multiple classes calling each other's method and whether they can pass around the value correctly or not. The visible structure that we have would be the modular structure of the software. So you can have, let's say, classes, how they are interact, or even at the level of the software architecture, like how many pieces of the module are connecting to each other and how they send and receive the information. In the integration test, we usually use a lot of scaffolding. So you need to be familiar with how to use mock objects to be able to do these kind of integration tests, because at some point you might not have fully every module available. So if you want to test them, you need to base on some mocking first. And the key thing that we are looking for in integration tests is we check for two things: interactions and compatibility. Interactions between the module and compatibility of the data that are passed around between the module as well. And for the system test, which we're going to discuss next, the system test will be the large size test where you have the full system fully developed. So when we test based on system test, we're going to check based on the requirement. So we check the requirement and then we see whether the system can do such requirements correctly or not. We don't have any structure now, so everything will be just the software itself. You might need some of the scaffolding, and we check for fault in the full system functionality. Okay, so this includes the UI as well that we discussed in the previous module. Okay, so to compare specifically between integration test and unit test, unit test is a necessary foundation. We discussed the pyramid, right? The Mike-Cone pyramid. This is unit test. This is integration test. And this is end-to-end test. Okay. So unit test are the majority part of your test cases. And then you have some amount of integration tests, and then you have the least amount of end-to-end tests. So unit tests help us to ensure the maximum controllability and visibility, because you can control the input very precisely to that specific method, and you can observe the output very precisely as well. So you need unit tests, and you cannot use integration tests as a compensation for inadequate unit testing. So next, let's move on to the integration test. So we should treat integration tests as a process check, okay? So if we try to do integration tests and we find some faults in the integration test, then they usually signal that we might not have adequate unit tests. And then you need to go back and write some more unit testing. And if we find the integration fault between the interfaces, we need to trace it back and go to the module breakdown and check the interface specification, okay? So what are the types of integration faults? So I can give you some examples here. So you might find some inconsistent interpretation of the parameters or the value. I talked to you in the very first module that there's a case of Ariane 5 where one team is using integer and another team is using floating point value. And they exchange the value that are different data types. So that caused the software to break, and then the rocket exploded, right? So there are other examples as well, like this mixed unit of meter and yard in the Martian spaceship, right? So you can read the story by clicking on the link. And there are some problems about violation of some value domains based on the capacity or the size, like problem with buffer overflow. And it might have some size effect based on the parameters or resources. Like when you have more than one classes or one code module working together on a same file, that same file may be conflicting. They got open and closed by two modules at the same time. It might cause some issue here. And it might has a problem with omitted or misunderstood functionality. Okay, the team might not totally understand the functionality and might have some inconsistency when you do coding. The other might be non-functional requirements like the performance issue and some mismatch that might occur during runtime when you call the metamorphic methods. Okay, so I would like to show you one example here. So this is a real example of a memory leak problem in Apache web server. So the Apache web server will accept some requests, HTTP requests. And this code, if you look at it, even if you do unit test, you might not find any error. So this is a C code, okay? However, it has been found that the Apache server actually kind of leaking the memory slowly or even quickly if it get the DDoS attack. But if you try to do some actual integration tests, you try to call this method. And if you keep calling this method multiple times, you might observe that there is this problem of memory leak. And that's because the code didn't free the pointer. So this is a pointer that keeps accumulating and it keeps leaking the memory. So this missing code can be found when we do kind of integration tests. Okay, so this fix is not impossible to find with unit tests, but yeah, by using other techniques like code review and some dynamic analysis or doing integration tests, we will possible to find it. And integration test is kind of test that many companies or many developers do not pay much attention to. So they might think that when they implement a module A, but they didn't test it enough, then they will wait for the module B. When it's ready, then they will start doing the integration test. But actually what they mean is that they do not have any strategy for testing and they didn't think about the order of testing. So actually the developers do not need to wait. They can start doing this kind of integration test right away when we start developing one single module. Okay, we're gonna talk about how we're gonna do this later on. So we can come up with integration plan and test plan. So we have the plan, the test plan, and also at the same time, the build plan. So build mean you compile and integrate all the module in your software. Okay, so we should have a plan. How do we test and how do we build? And it should go along together over time. Okay, in the next module, we're going to discuss the concept of continuous integration and continuous delivery, where you can have the build and the test going together at the same time. So if the developers wait until the end and they do the integration test, we call this a big bang integration test. And this is a pretty bad approach. So if you test only once after integrating all the module, you might think that it's good because you don't need to have any scaffolding. Okay, you might have everything already ready and then you just do integration. But the problem is that you do it at one time. You can observe not a lot, right? You might miss some kind of observability of the output. You might not see some kind of efficiency or performance of the system. And to wait until the end, we have a pretty high cost of repair. If you still remember, I showed you this graph before. This is the concept of shifting left, where we want to shift the testing to be mostly on the early phase as much as possible because the cost of fixing the problem getting higher and higher. So integration test is here. If you wait at the end, you might go into around this phase, right? And that's even already high compared to the very first part of the development. So we shouldn't wait. And what should we do then? You can try doing integration tests along the way when you develop the software. And there are two strategies that help us. The first strategy is called structural orientation, where we test based on the structure of the module. And the second one is called functional orientation, where we do integration tests based on the function of each feature inside your software. Okay. And the key things that we need to understand before we discuss each of the strategies is that there are two key things that we need for integration tests. So if you are testing this module, and this module depends on the other module below, if you want to do tests while the sub module are not ready, we need to create what's called a stub. So a stub is a dummy module that used to simulate the low level module. Okay, so these are the module that got called and they are not ready yet. They are still under construction. And we use this concept of stub in the top-down integration test approach. The next one is called a driver. So a driver is when if you want to test this one, and this method has need to be called by another method, which is higher level than it. So we're gonna create a driver, which is a dummy module that used to simulate the high level module of the module that we are testing. So this is a calling module that kind of call the method being tested. This is when we have the main module still being under construction, and we might use it during the bottom-up integration. Okay, so for the structural orientation, when we're gonna do integration tests, let's start with the top-down integration testing. The first way is to do top-down, which means we start from the top to the bottom. We will start implementing the main module at the top first, and then we're gonna start implementing the module below and coming down to the bottom. Okay, so this one we have two techniques. So the first technique is depth first search, and the second one is the breadth first search technique. If we have these 8 modules, we can see that the M1 is the main module, and then you have M2, M3, and M4 as a sub module of M1. And then you have M5, M6, and M7 as the next level module. And then you have M8 as the last module. So if you are going to do top-down integration testing using breadth first search, we're going to do like this. Where when you're implementing M1, you will test it with a stub of M2, M3, and M4. Okay, because M1 depends on M2, M3, and M4. So we need the stubs from all of them. And then the next step, so the first step is here. The next step is you move to M2. So when you implement M2, now you need to start testing with the stub of M5 and M6. And when you also testing, so the M2 will test with the stub of M5 and M6. But if you test both M1 and M2, then you will need the stub of M3, M4, M5, and also M6. All right. And next, you move to implement M3. So when you implement M3, you're going to test it with the stub of M7 only. But when you test all with M1, M2, and M3 together, you're going to need the stub of M5, M6, and M7. Okay. M4 as well, sorry, M4. M4. Okay, so you keep doing this in a breadth first search manner. So you come here and then you go here, you go here, you go here. The next one is going to be M5. And when you do M5, you're going to test it with a stub of M8. And then you move to M6. And then you move to M7. And lastly, you will implement M8 as the last one. And that would be finishing of your implementation and integration testing. The next one is called depth first search. So for depth first search, we're going to go deep instead of going breadth. So we start with M1. When you do testing M1, you're going to test it with a stub of M2, M3, and M4. And then you're going to go to M2. When you do M2, you're going to test with a stub of M5 and M6. And then you're going to go down to M5 first because it's a depth first search. and you're gonna test it with the stub of M8. And then you build next M8, right? And then you backtrack. So you come down here, come down here, come down here, and then you backtrack to here, and then you implement M6, and you don't need any stub. You backtrack again, you come back to M1, and now you come to M3, and then you're gonna implement M3, which you need the stub of M7. And next you come down to M7, and then you implement M7 without any stub for testing. You go back, you backtrack, and then last one you implement M4 as the last one. So the order of implementation and testing and the order of the steps that are needed are different between breadth first search and the depth first search. Okay. So when we do this kind of top-down integration, we would have the main module as a test driver because it's the top one. And then we use the stubs for all the components that are the subordinate of the main module. When the actual component are being created, that's when we replace the stub. So we keep testing when each component is implemented and integrated, okay? So this technique you can start implementing while still having some code that are not ready yet. So one more example about the top-down approach. So you start working from the top level, okay? And then, yeah, you come down, you have a stub of A, stub of B, and a stub of C. So with this, you don't need any driver. So you just implement A, and then you have the stub of X and Y. And then you start implementing B and C, right? And then you start implementing the last two, which is X and Y. And now everything is complete. So with this kind of top-down strategy, it goes from the top. So that main module or the major module must be already decided what it is. And this kind of top-down help us to early recognize any major problem because it goes from the top. And then the depth first search strategy allow us to complete one function because you go down to the bottom first and then you come back again, right? And then the stubs, we'll use them to replace the lower module. And then we can replacing the stub as long as we keep developing and we replace the stub with the actual implementation. The next one is called a bottom-up approach. So the bottom-up approach, instead of starting from the top, we're now gonna go from the bottom up. So you start your implementation from the leaves, okay? And now we don't need a stub, but we will need a driver. So X needs to be called by something from the top. So you will implement that as a driver, which is a mock version of the parent of the caller of the module X. So with this kind of bottom-up integration, we start with the low-level component first, and then the driver will be needed so that we can write the test, right? So it's a totally different direction from the top-down integration test. So in bottom-up, let's say if you have the same kind of software with the 8 module, you're gonna start by doing M8 first, and then we need to have the driver of M5, right? So start with the M8 having the driver for M5, and then we do M5, and now we need to have the driver of M2, okay? And then you can move to M6, we still have the driver of M2, then you move to M7, and then you have the driver of M3. And now if you move to this one, we need a driver of M1. And then you can implement M3, M7, and then implement M1 at the end, okay? Okay, so in the bottom-up approach, okay, we construct the driver first. So let's say you have X and Y, you're gonna need the driver for both of them. And then we replace the driver with the module that you implemented. That module needs another driver, so we add the mock of the code of the driver. And then you keep adding the driver and you have a new driver for that particular module. So you keep working on this, and we will have several working subsystems like this one, and this one. And eventually you would go up to reach the top, and that is when everything is fully implemented and integrated. Okay, so this one start from the bottom. You don't need the stubs, but you need the drivers. Okay, you check the bottom level very thoroughly, so the operational module are like fully checked. The next kind of structural integration is that we can use sandwich integration, which is the combination of the bottom up and the top down. And with this, we go from the top down approach from the top layer, and we go bottom up from the bottom layer. So with this, we can integrate both from the top and the bottom at the same time. So with this, we would need to have some both stubs and driver at the same time. So it will look something like this. If we do sandwich approach, you're gonna start with having this implemented and also having this implemented. So this one will need this stub, okay? And then you keep adding the code from the bottom, and you also add the code from the top, and then that's where the sandwich meet, and then everything is done. Okay, so we have discussed a few techniques that rely on structural orientation. Next, we're going to discuss the integration test technique that depends on functional orientation. So for functional orientation, we care about the function or the features. Okay, so we test based on the function or the feature. And the first technique is called a thread. So instead of caring about which module is going to build first, we care about which feature that is building first. So let's say we have the first feature, which might be a login feature, F1, login. So the part that are responsible for F1 in all of the module will be created and tested first. And then you might have F2, which is a registration module. So now you have both F1 and you start adding the new functionality F2. So this is for F1, this is F2, this is F2, this is F1. So you keep doing these slides or having a thread of each feature, and then you have the integration test for each of the feature at a time. And we keep doing this until we cover all the features that we have in the system. Okay, so with this technique, you might not need any stubs or driver at all, or you might reduce the amount of stub or driver that is needed because each of the module will already be implemented at the same time. So which strategy to choose? There's no right or wrong answer, but you might need to think about the pros and cons. So functional strategy requires more planning, okay? So for the structural strategy, like bottom up, top down, sandwich, is pretty simple. But if you do the things like the threads or these kind of functional based orientation, you need to think about what should be the slides that you're gonna do and how you would separate the test into each function. So you might be able to combine the top-down, bottom-up, or sandwich approach for a small system, okay, for the relatively small component and system. But the threads orientation may be better for a larger system because you might not be completely building one module at a time, but you can build one feature at a time easier in that case. Okay, so that's all for integration testing. I would like to sum up what we learned. So the integration test focus on the interactions between the module, and we build on the strong foundation of unit tests. And we try to have the order of orientation that we integrate the software, and we discuss top-down, bottom-up, and the sandwich technique. And we also discuss about the thread technique that you rely on the function of the software and integrates based on those functions. And that's all for this module. See you in the next module.